Hello, this is Mr. Stansbury. I'm going to take you through the 13F assignment. All right, number one, Casey deposited $50,000 fixed term account for 5 years with interest of 5.7 per annum, compounded quarterly. Inflation over the period averages 2.3% per annum. Okay, so find the value of her investment after 5 years. So, part A. So we have A equals, we got our 50,000 times 1 plus the rate, which is 0.057, all over the number of compound periods per year. So if it's compounded quarterly, then n is going to equal 4. So that's going to be over 4. And it's going to be all to the 4. Those are the same numbers there, times the number of years. So this says 5 years, so 4 times 5. All right, so we're going to just put this here into our calculator. So we're going to do 50,000 and then times 1 plus 0.057 divided by 4, all to the 4 times 5 is 20, right? And that gives us 66,354.49. 66,000. What was the rest of that? Let's see, 354.49. Okay, so that would be how much it's worth, the investment, if she were to cash it out, or he were to cash it out. Oh, it says her. So if she were to cash it out at the end of the 5 years, then that's how much she would get back. Now, calculate the value of the $50,000 index for inflation. So in other words, $50,000 today is not going to be worth $50,000 in 5 years. It's going to basically have a different amount, right? Because it's the dollar is getting less and less valuable because of all the inflation. So what we'd want to do with that is A equals 50,000 times 1 plus the interest rate. The inflation rate is 2.3, so we're going to actually just do 0.023, because that's always annually, so that's over 1, and then that's for 5 years. So now we're going to figure out what the inflation rate is going to be. So 50,000 times 1 plus 0.023, all to the 5th power, gives us 56,2065. Okay, so that means something that cost $50,000, 5 years later, that same thing should cost $56,020.65, the exact same thing. So because of inflation. Okay, find the real increase in value of her investment. So really, that means that she's only actually gaining. We take our 66,354.49 and take away our 56,020.65. So we subtract those two from each other. We 66,354.49 minus 56,020.65. We get that really the actual increase is 10,333.84, right? Yes, so that's what she really gained if we take out the interest part. And then part D says, what's the real average annual percentage increase in her investment? So it's basically you're getting 5.7% back, but you're losing 2.3 because of the interest rate. So you can't actually simply subtract those two, though that will get your answer really close. But it won't get you the exact answer. So here's what we want to do. You want to start with your ending amount, which is our 66, 354.49, and then you're going to go with our starting amount, which was 50,000, but we're going to actually index it for inflation. So we're going to use this number here, our 56,020.65. So that's the beginning amount, that's the end amount. And then we end up with our, so we want to do 1 plus, and then let's see, what's the real average annual? So that's just going to be the rate over 1. So that's going to be 1 plus R, put it over 1, so let's do 1 plus R. And then that's all for, what, 5 years? Okay, so now we got to solve this. So divide by 56,020.65. 56,020.65. And we get, let's see, 4.49 divided by 56,020.65, and we get 1.184 equals 1 plus R all to the 5th. So we've got to take the 5th root of both sides here. So we get 1 plus R over here equals, so now we're going to want to do the 5th root of our answer, which gives us 1.0344. Subtract the 1 from that, and we get that the rate is 0.0344, or the rate then as a percent is going to be 3.44%, would be the actual interest that she's earning if you take out the if you factor in the inflation amount. All right? Okay, that's a good one. Number 2, Gino invested $20,000 in a fixed term deposit for 3 years, interest of 3.85, compounded monthly. They give you the inflation amount. So it looks like they're asking the same thing as number 1. So what's the value of Gino's investment after 3 years? So let's see, we've got the amount will be 20,000 times 1 plus the rate, which is 0.0385, divided by the number of compound periods per year. So since it's monthly, n is going to be 12. So that's all over 12. And then there's a 12 there, times 3 years is going to be a 3 there. So let's calculate that out. And we get 20,000 times 1 plus 0.0385 divided by 12, all to the 12 times 3 is 36th power. So we're at 22,444.54. Is the amount that they that Gino will be able to withdraw at the end. B, index to 50,000 for inflation, so that's going to be, oh, this says, that's interesting, this says 50,000, this should read 20,000. Okay, so let's change that to a 20,000. Right, and let's see, our inflation is 1 plus 0.034. Again, inflation is always calculated over the year, or at least everything in this, all of our examples here do. And then this is for 3 years. So let's figure out what that gives us. So 20,000 times 1 plus 0.034 all to the 3rd power gives us 2,210.15. Okay, so that's how much that 20,000, what you can buy for 20,000 1 year. Let's see, 3 years later is going to cost 2,210. Okay, so part C, calculate the real increase in value of Gino's investment. So that's going to be 22,444.54 minus 2,210.15. Looks like Gino's not getting a great deal here. 22,444.54 minus 2,210.15, and has gained interest of $334.39. That's the real increase. So the real average annual percentage increase is going to be, again, they're going to end up with like what you could pull out. So that's the 22,444.54. Oops, let's see, I don't need the equal sign here. I need it over there. And that's going to equal, and then it's the indexed, the inflation, indexed inflation here. So that's our 22, 1, 10, 15, right? And then we're going to figure out what the actual interest rate is. So 1 plus R, and then this is for 3 years, right? So divide both sides by 22, 110, 15. Right, we get 1 plus R to the third is going to equal 22,444.54 divided by 2,210.15 gives us 1.0, what was that, 15. But again, we got to take the third root of those to get rid of the power there, and we get 1 plus R is going to equal, now let's see, this actually has a third root button right here. So we'll do the third root of our answer, and we get 1.005. 1.0050. Subtract 1. And we get that R equals 0.0050, which means an actual increase of 0.5%. That's pretty crummy. So yeah, inflation gets you, so you got to make sure that you're taking that into account. All right, next problem. Number 3. Jordan leaves $5,000 in an account paying $415 compounded annually for 2 years. Inflation runs at 3.5% interest in year 1 and 5.2 in year 2. Has the real value of the $5,000 increased or decreased? So let's find that out. Okay, so let's find our current amount. Let's see, that's not even part A. Let's see. We've got our amount is going to be 5,000 times 1 plus compounded annually, so it's 0.0415 all to the second power. So this will be how much money they'll be able to pull out of the account. So let's see here. Let's do 5,000 times 1 plus, so let's just do 1.0415 squared, right? So 54,2361. Okay, so that's how much they'll be able to pull out of the account after 2 years. So now what we want to do is also we want to figure out what the inflation piece is going to be on that, right? So we take the amount after the first year is going to be 5,000 times 1 plus the rate, which is 0.035, and that's just for 1 year. So really, it's just going to be 5,000 times the interest, right? Plus 100%, so 1.035 gives us, after the first year, it's 51.75, right? Is how much with the inflation. Okay, so then now you got to take that 51.75. 51.75, and now you got to add on the 5.2% for the interest in year 2. So 1 plus 0.052. Right? So we take that and multiply that by 1.052, and we get $5,444.10. Is the amount. So that $5,000, what you could buy with $5,000 is going to cost you $5,444 in 2 years. And look at that. It's not like inflation has gone faster than the interest that he's earning. So has the real value of the $5,000 increased or decreased? It has decreased. Right, because this number is bigger than that number, so it's decreased by what, like about a little more than $20. So that's a bummer. Sorry, Jordan. All right, number 1, Mandy invests $15,000 in 2002 in a term deposit for 3 years at 6.15% interest compounded quarterly. Inflation over the 3-year period averages 4.3. Calculate the amount in the account after 3 years, and what's the value of the deposit in 2002 dollars. All right, so first thing, let's figure out the amount that she invested is $15,000. 1 plus 0.0615, and it's compounded quarterly. So n is 4, so we got a 4 here and a 4 there, and calculate the amount in your account after 3 years. So we got the 3 years there. So let's do 15,000 times 1 plus 0.0615 divided by 4, all to the 4 times 3, which is 12th power. This $18,013.95. Oops. All right. There we go. Okay, so for part B, we have to find what is the value of the deposit in 2002 dollars. So what we're going to do is take this $18,013.95, and you're actually going to divide it by the inflation rate for however many years it is, and this is for 3 years, right? So we're going to take that and divide it by 1.043 to the 3rd power, and that should give us what the value is in 2002 dollars. So we're going to take 18,013.95, divide it by, let's do parentheses, 1.043 to the 3rd. Okay, it gives us 15,876.55. Okay, so 15,876.55. So with the value of the deposit in $2,002. So basically, if you are comparing the two amounts here, basically she's gaining $876.55 in $2,002 is basically what that's getting at. Okay. All right. Let's take a look at the next one here. Suppose Francis deposits $8,000 in a term deposit account at the start of 2003 and receives 4% per annum interest compounded monthly. What amount is in the account after 10 years? Okay, so let's figure that out. So we got the amount's going to be 8,000 times 1 plus, let's see, the interest is 4.8 and it's compounded monthly. So n is 12. So we got 1 plus 0.048 over 12, all to the 12 times, and this is after 10 years, so that's a long time to invest that money. Let's see what it's going to end up at. So 8,000 times 1 plus 0.048 divided by 12, and we're going to take that to the 12 times 10, so to the 120th power, and it's going to be worth 12,916.22. Okay, so after the 10 years, it's going to be worth 12,916.22. Okay, part B. 1 says, what is the value of the investment in $2,003 if inflation is expected to rise by an average of 2.5%, 3.5, and then 4.5? Okay, so we're going to take this 12,916.22 divided by 1.025, because that's 2.5 plus the original 100%, all to the, let's see, 10 years, right? So let's try that out. 12916.22 divided by 1.025 to the 10th. Okay, so we end up getting this here, this $10,090.13. Okay, so what's the value of the investment? So it's going to end up being still going to be pretty good. Got over $2,000, but granted, Francis had to leave it in there for 10 years, so that's quite a while. All right, so let's do the other ones. B, I, and this is going to be the same number, 12,916.22, and now we're going to divide it by, instead of 2.5%, we're going to go 3.5%. So 1.035 to the 10th. Okay, and then a nice little thing on your calculator here. If you do second entry, it'll pull up the entry that you just did. And then so now what I can do is just go over here and change the 1.025 to 1.035 and then push enter. So now we're at 9156.55. Right? Okay. And then the third one here is now the same thing. 12916.22 over now it's at 4.5%, 1.045 to the 10th. Second entry, go up and change that 3 to a 4, and now we're at 8317.11. Okay, so really that means like if it's going up at 4.5 and you're only getting 4.8%, you're not gaining a lot of interest every year. So that would only end up making $317 if you compare it back to the original, the in the $2003 versus over 2000 if the the inflation was going on only up by 2.5. Okay. All right. Number 4, start of 2003, John leaves 3,000 in savings account, paying 5% per annum interest compounded annually, whilst he travels overseas for 4 years. How much will there be in John's account when he returns from overseas in 2007? Well, first off, John, you got to find something a little bit better than 5%. 0.5%. That's not very good at all. Anyway, let's see. We've got the amount is going to be $3,000 times 1 plus compounded annually. So n is going to equal 1 here. So 1. Let's just do 1 plus 0.05. And then for 4 years, so then we're going to have to the 4th power here. So 3, oops, 1 too many zeros, times 1.005 to the 4th. I've made $60 over those 4 years and 45 cents. 3065 point, what was it, 45. Okay, so that's what he is going to end up with when he comes back. B, if inflation has averaged 4.2% per annum over the 4-year period, what's the value of the account in $2003? Okay, oops. Just realized that I messed up here. This is supposed to be a 0, not a 5. Sorry about that. Okay, so now we're going to for part B, if inflation was 4.2 over the 4-year period. So what's the value of the account in $2003? So we got to take our 30, 60, 45 and divide it by 1.0, let's see, 42 to the 4th power to see what has then happened also because of inflation. So we got 3060.45 divided by 1.042 to the 4th. And that gives us 2596.06. Right? So, John's losing value on his investment, but oh well, what do you do? So it says, what interest rate did John need to invest at to make a real return on his money? Right, so it'd have to be really he'd need to have part C. He needs to have an investment that's more than 4.2% per annum. Okay, since this is a compounded annual, also he only got 0.5%. He needs to have 4.2% just to break even, and then if he's getting more than 4.2, then he's going to actually make a positive return on his money. All right. Okay. Last question. Number 8. Find the future value of a tractor which is purchased for $48,000 if it depreciates at 15% for 5 years. By how much did it depreciate? So, future value of a tractor depreciates at 15%. So we got the amount is going to be started at 48,000, and we do 1, and now it's depreciating, so it's a minus 0.15 for 5 years. Okay, so we can just plug that in, and we're good to go. 48,000 times 1 minus 0.015. Oop, not 0.015, but 0.15 to the 5th power. gives us 21,297.86. Right? 21,297.86. By how much did it depreciate? A lot. But let's figure out how much it is officially. 48,000 minus 21,297.86. So we'll do 48,000 minus our 21,297.86, and we get that depreciated by $26,702.14. Right? That's a lot of depreciation. But I guess that's what happens with, especially with things with engines that tend to break down and wear over time. All right, that's all there is for the 13F assignment. If you have any other questions, please ask in class. Thanks.